enterprise at JPL. So Benjamin, are you on?
Yes, I'm on. Can you hear me?
There you go. Yep, loud and clear.
All right, let me try to share this. Can you see this?
Yes.
Great. Hi, everyone. I'm Benjamin Nuemberger from JPL, and I'll be telling you about our work using XR for engineering mostly, and then a little bit more recently about general enterprise use cases. Before I jump into the engineering use case, I wanted to mention that there's a bunch of different things that JPL has done in the past related to AR, VR. I just wanted to show you some of them here, just so you're aware. If you want to follow up later on offline, some things related to Mars, ops and planning, robotics. The one in the middle I'm going to talk to you about today, orbit visualization, public outreach, and some more volumetric VR work. But today I'll be focusing on an application called Protospace, and I think the next slide shows a video. And so Protospace basically is a collaborative CAD visualization tool. We mostly use the Microsoft HoloLens. We've been using it at JPL for several years now. It's had a lot of success helping out engineers and scientists in various ways. Here you see some of the screen captures from the HoloLens. And basically it has several parts. One is we have a web server with a custom model decimation pipeline where you can upload a CAD model, reduce it so that it still maintains high fidelity in the parts that you want to discuss about, but reducing the fidelity in other parts so that it can render on the headset. And it's collaborative. You see here people discussing something collaboratively. And in the headset, there's also different tools that you can use. There's a move tool, move the CAD model around. There's a rotate tool to rotate it. There's cut planes and scaling tools. And you also can create different views, we call slides, that you can step through different views of the CAD model based on how you want to do your discussion. So we've been using it in the full mission lifecycle. Anything from pre-phase A, earlier concept studies and proposals. SphereX used it for one of their proposals. And then as you go on into the early design phases where you don't have anything built yet, you're still trying to design it out. Roman Space Telescope has been using it recently a lot. Of course, Mars rover, Perseverance, helicopter, Ingenuity, they've been using it in the past. And then later on, as you go further into actually, fabricating and integrating all the different components of the spacecraft, folks like NISAR, which is a joint collaboration between NASA and the Indian Space Research Organization, they've been using it a lot in high bay clean rooms. And then a little bit in the operations phase, we've had some work with Cold Atom Lab on the ISS, and then I'll mention a little bit later about the Vital Ventilator project related to the pandemic. So I'll jump into each of these main use cases now and just give you a flavor of how people have been using it. The first one, again, is early on in designing spacecraft. And this helps teams basically communicate better. I think that's why we're all here with XR, right? It's a novel communication platform, medium, so to speak, that allows you to communicate in ways you couldn't communicate otherwise. So we've had people, talking about different decisions, and we have anecdotes like this here where people were going back and forth over email for months, but then once they put on the headsets, they can immediately know the answer within a couple of minutes. So I think I saw someone from APL in here. We've worked with APL doing non-collocated sessions. That's been great in the past. And of course, here a lot of the times it's just in a random room at JPL doing a discussion. And sometimes people bring in actual tools to see if the actual assembly later on will be okay and try to reduce the risk. it's hard to see right here, but I think this person's using a certain tool. So there's actually one time where someone was trying to rehearse a procedure that they knew they had to do later on. And because they were able to see this in augmented reality beforehand, they realized this procedure is going to be really risky and it's going to be hard to do it later on in the life cycle. So they actually updated the design early on, which allowed them to potentially save millions of dollars down the road for a very risky procedure that either they would have to incur a lot of risk and add some more safety margins, or fully redesign later on in the life cycle. And speaking of later on in the life cycle, once you get to integration and tests, we've been using this a lot here with NISAR, visualizing the CAD model with respect to ground support equipment to make sure this ground support equipment is usable, so you don't have to buy new ground support equipment, overlaying cabling, doing remote collaboration sessions, showing off how you might want to move a CAD model into a test chamber before actually moving it there to make sure everything will work as planned. And of course, there's general presentations. This is a little harder to quantify the value of, but basically it helps get the point across to your stakeholders. PDRs, CERs, VIP visits, demos, just seeing the full scale of something really makes a real big difference. I'm sure all you know this from your work as well. And some of the recent usage, we've had the chronograph instrument doing some instrument integration and test discussions back in October and November. These are cases where you just have people in a conference room collaboratively, viewing the CAD model. We have all-day sessions where they come in, put on the headsets, have a great discussion, and find out a lot of potential issues early on. Here's a remote collaboration example. In person, we're in the HoloLens, and then we stream the view over WebEx, and people from home can join in the discussion as well. Again, mentioned NISAR several times. We've had, engineers regularly using Protospace in high bay and clean rooms, and they pretty much use it on their own now. A lot of the challenge in a lot of this technology is you got to handhold people, for all the sessions or demos. But this is a great example where the actual mechanical engineers are now pretty much using it by themselves and getting great value out of it. And of course, we do, have high VIP demos as well. So that was the main use cases. We also have experimented with doing step-by-step procedures in XR. This one was at NEMO. We've collaborated with Lei Wang's group in the past. This one was a few years ago. We had a step-by-step procedure in the underwater habitat. This is an analog environment off the coast of Florida, where astronauts and scientists can go to simulate living in an extreme environment, such as pretending to be on maybe a lunar surface. They go underwater, do spacewalks to simulate lunar EVAs. And this one was pretty successful. We designed the procedure beforehand. You can't actually get there, to test this out beforehand. So we have to go in there. We have to, design it beforehand, and we actually had to update the procedure right before doing this when they actually did the mission. So there were 2 astronauts and 2 scientists here who participated in this, and they saw the value in doing this. This one, Cold Atom Lab, we have, this was a controlled experiment where we actually had 20 participants come in and test out paper procedures versus augmented reality procedures. And with this one, we showed that using augmented reality, you can actually increase your speed at performing these very simple tasks. This is just a mating or demating cables task. And it also reduced the cognitive load on the user using the NASA TLX questionnaire. And there were a little bit less errors in the augmented reality case, but that wasn't statistically significant. This one and the NEMO one you can read more about here or ask me as well. And this research won a Human Factors Prize. We also have done some procedures on the web more recently using Protospace to author these. So the Vital Ventilator was a project about 2 years ago now, right at the start of the pandemic, where a bunch of JPL engineers got together and said, hey, how can we help with the pandemic? So in about 30 days, they designed, tested, got FDA emergency approval for a ventilator designed specifically for treating COVID-19 patients using parts and components that wouldn't prevent the more medical grade ventilators from being manufactured. So our part in this was to design and build out some interactive assembly instructions for the people who would be licensing this technology. So we have a little interactive viewer, there's videos and step-by-step procedures that you can walk through. And we've also applied this to some of the more future looking projects such as JPL EELS project as well. And here you see some of the UCLA doctors and medical staff testing out the ventilator. And finally, I want to wrap up with some things we've been looking at recently. This is nothing that we're building ourselves. We're just looking at commercial off-the-shelf stuff. But basically the future work, as we go to be more remote workforce or hybrid workforce, how can we still capture the collaboration aspects that you would have in an in-person work environment? You can't fully mimic the in-person through this technology, but we want to see what's possible. So we've been 3D scanning some physical rooms at JPL, putting these into some VR meeting apps, and one of our managers likes to call this "Welcome to our metaverse," play on "Welcome to our universe." So we've been testing this out. If anyone else is testing this kind of stuff out, I'd love to hear what you found. And we have actually been holding some meetings in some of these VR environments and some non-VR environments as well. Here are some videos just showing, this is just using the Quest 2, moving around one of these 3D scan environments. Arguably, these were scanned just with an iPad. So 15-minute scan, not much post-processing required. You can do a high-end lighter scan, but what we wanted to do is just see what's possible in a few minutes just to get these scans into a VR environment. And the nice thing about a lot of these iPad apps are that you can scan it real fast, not much post-processing required, and you can upload it to some of these VR meeting apps. So we've been testing a bunch of them. Spatial I/O is a pretty good one. Mozilla Hubs also allows you to import some of these 3D scans as well. And then this one's kind of a fun example showing, you can do kind of like a hybrid AR VR experience. So on the left here, you see a view shot from the HoloLens, and you're in person on lab, and then someone at home in the Quest seeing the 3D scan room, but we still have these avatars, so that way we can have this kind of social being together presence. So it's pretty magical, but once you put it on for the first time, it kind of feels like you're both there, whether you're remote or you're in person. It's kind of fun to play with. So you can imagine someone who's remote, who's an expert, who can't physically come onto lab, and guiding someone who needs help through the space. So this is mostly just testing, but we see some potential here as well. And that's it. So yeah, thank you for listening. And yeah, if you have any questions, would be happy to
Yes,
answer them.
we do have a couple of questions and a comment in the chat session. So Kirsten asks who can get and use Protospace.
Who can get and use Protospace? Yeah, we've had it licensed out to different groups before. We've transitioned kind of upper management control of Protospace at JPL recently. So we just take it on a case by case basis. So if you'd like to hear more, just send me an email and we can talk through the details. But in the past, we have licensed it out. APL has used it a lot in the past, and then at least one or two other groups.
All right, and Ron had a comment. Ron, did you want to verbalize your comment, or just read it off the chat session?
Oh yeah, thanks so much. I'm Ron from Carnegie Mellon University on the NASA Suits Student Challenge. So for HoloLens 1 and 2, we sometimes see like issues with holograms kind of staying put on a particular spot as you move closer and further away or look at it from different angles. I think this is something that's kind of particular to you guys' scenario where you want your mechanical designs to be super accurate no matter what viewpoint you're looking at. You can't have it drift slightly when you're stepping 5 meters away, for example. I was curious to know if there's something that your team does in particular to kind of really alleviate some of these precision and anchoring issues.
Yeah, that's a great question. We don't do a whole lot, but basically the approach we've taken is we have an image marker basically somewhere in the physical environment, and then all the users scan that, and then that's our spatial anchor. And then we move the CAD model, the virtual model, to be in the right spot with respect to that. And you know, the HoloLens has great documentation. You know, they say as you get further away from that spatial anchor, there's more drift. The interesting thing for us is that most of our use cases tend to be, you know, they need pretty accurate alignment, but a lot of these discussions are more general, and they talk about things that are even not in the CAD model. You know, there's like ground support equipment or cabling or thermal blankets, things that you don't model in the CAD model. And as long as the virtual to physical alignment is good enough, you know, within several centimeters, then you can have a great discussion. And if it drifts a little bit, that's okay. So we've looked into, you know, doing some more accurate model alignment, but so far just using that image marker on the ground, placing it close to where you want to do the discussion, you know, from that vantage point, so you get not much drift, has been really successful. So we haven't had the need, basically because the customers haven't complained to us that they've been experiencing too much drift. But of course, there's things like, you know, as the model size gets bigger, then, you know, it's not going to look as good. It's going to render more slowly, and there's a lot of other potential, you know, little things that you can tweak to make it better. But I'd be happy to answer more offline.
Right, thank you so much.
And just a quick comment, we're also looking at creating hybrid workplaces, similar to you. We're planning to scan some of the conference rooms and labs. So I'll follow up with you to sync up on both of our activities.
Sounds great.